We type a sentence on the screen, and somewhere else in the world, in a place our eyes can't see, thousands of machines heat up and cool down again. Every answer that comes from ChatGPT has an unseen cost: water and electricity. What we call the cloud isn't actually in the sky, it lives in large buildings set on the edges of cities in the middle of wide tracts of land. While our fingers hit the keys, something is happening there. Current flows through cables, chips heat up, fans spin, water moves through pipes. Behind a single line that appears on your screen, there's a world like this. And as long as we don't notice it, the more our questions increase, the more that world's burden grows. So, how does this work? How does it touch us? And how can we play a more conscious role in this story? Come on, let's jump into the video and see how it happens. Think about it. You type, "Hello, how are you?" on your computer. A few seconds later, the reply arrives. It looks like a simple exchange, but a lot happens in that short moment. It's as if a conductor raised the baton and hundreds of instruments started playing the same note at once. Servers wake up, data shifts places, algorithms run. That work produces heat, just like our bodies warm up when we run. As heat rises, it becomes harder for the machines to work correctly and quickly. That's why cooling steps in. Cold air or water gently takes that heat away and carries it out. In some places, you see a fine steam rising from towers. That steam is actually one way the heat inside is carried outside. Elsewhere, water circulates in a closed loop. It takes the heat from inside, gets cooled somewhere, and is sent back again. Which method is chosen depends on the climate where you are, the city's infrastructure, and the design of the facility. As for the question, where is the cloud? The cloud sits by roads, at the edges of fields, sometimes next to industrial districts. It exists on the flat plains in the middle of America and in the tech corridors just outside major metros. In Europe's cooler climates, in Asia's coastal cities. Why these places? Because being close to power lines, having access to water infrastructure, and benefiting from climate all matter. Cool, windy regions provide natural support for cooling. Near the coast, seawater can play a role in carrying away heat. In dry and very hot areas, water planning is more sensitive. You need different strategies to do the same job. Now, let's come back to daily life for a moment. Before heading to work in the morning, you ask, "What should I wear? What's the weather?" In the evening, give me 3 quick dinner recipes. At work, can you rewrite this draft in a clearer tone? As a student, you ask, "Would this title be more compelling?" All these small requests save us a few seconds. Overall, our lives flow more smoothly, things speed up. But behind every acceleration is the same story: electricity, heat, and water. When there were fewer users, this world remained small. Today, millions of people ask AI questions billions of times each day. Movement on that scale inevitably touches city planning for power and water. Let's be clear about this. Making a single operation efficient is good. For example, a system that can give the same answer using less energy is obviously a positive development. Using closed-loop cooling, reusing water again and again, shifting workloads to cooler hours on hot days, all of these are the right steps. But there's a reality called the total. When the number of users grows fivefold, even if each individual operation becomes more efficient, the overall total can still rise. When customers arrive one by one, the shop door opens rarely. On a crowded day, it stays open, and keeping the inside cool is harder. Today's situation is a bit like that. So why do we see different answers online to a question like, "How many drops of water does a single query cost?" Because everyone is looking from a different angle. Some focus only on the water used inside the building. Others add the water consumed in producing the electricity that building uses. Some measure in a cool and humid coastal city, others in a hot and dry region. Some take data from nighttime, others from the midday heat. Naturally, the numbers change. What matters here isn't a single correct figure, but a transparent and simple language. Where, when, by which method, approximately how much. When we give clear answers to these four questions, cities, companies, and we users can all meet on the same page. Comparison questions like, is ChatGPT better or Gemini, should be handled similarly. If we want to be fair, we first have to be clear about what we're comparing. Are we comparing producing a text of the same length? Are we looking at similar climates and similar cooling conditions? Are we counting only the water in the building? Or are we also including the indirect water in electricity generation? When we apply these filters, the question who uses fewer resources gains meaning. But again, we return to the big picture, total usage. If a system is used far more often by a much larger group, even with good per unit efficiency, the overall load on cities and infrastructure can become noticeable. Cities' approaches to this are maturing over time. Municipalities are saying, yes, the technology is here to stay, but this city's water and electricity are finite. So let's sit at the table. In some places, facilities and cities make hour-by-hour agreements. On very hot and very dry days, water draw is reduced and workloads are shifted to cooler hours. In rainy seasons, closed loop and recovery are used more. In some cities, the waste heat from data centers is fed into district heating systems in winter. Thus, instead of one-way consumption, a two-way exchange is established. The energy used for information contributes to the warmth of homes. This is a scenario where everyone wins. The city can breathe, the company gains reputation, and the user experiences a technology that feels more reassuring. We can remember this whole picture with a simple analogy. AI is like a very fast team working in a huge library. The more questions come in, the faster the team has to run inside. A running team heats up. The library must be kept cool. If the questions come in the cool of the morning, everyone relaxes. If they flood in back to back at midday, cooling becomes harder. Sometimes the library wants to tell readers, ask your 3 questions on the same topic at once. Let us catch our breath in between. And if we, the readers, ask a bit more clearly and cleanly, the team inside finds the right shelf by the shortest route. What can we users do? First, it's a good habit to ask, what do I actually want? Instead of long and indecisive questions, a clear, targeted one both yields better results and produces fewer repetitions. Instead of sending 5 small requests one after another at the same time, asking them in one package, if possible, saves us time and eases the load inside. Asking for a short, clear, written summary instead of unnecessary meetings, requesting a more concise text instead of pages of drafts has the same effect. These seem small, but they are steps that, in total, ease the system. What can companies do is also clear. Make cooling smarter, keep water in closed loops whenever possible, use treated water instead of clean drinking water, store rainwater, reduce workloads during the hottest hours, and increase them during the coolest. Share waste heat with the city, build new facilities in regions with low water stress, and most importantly, share all this regularly in a way everyone can understand. This month, we reduced daytime water use by this much. We worked more efficiently at night. Our rainwater reservoirs provided this. Sentences like these can be as powerful as a formula or a complex table because they speak in human language. And if you ask, what about the future? We can picture 3 simple scenes. First, a scene of intelligence that protects water. Technology that collects rainwater, uses closed-loop cooling, works intensively during cooler hours, and gives waste heat back to the city. In this picture, we users also ask our questions more cleanly, not more than needed, but as needed. Second, a scene of old habits. While insisting that everything always be as fast as possible, we go full throttle in the midday heat of a high water stress region. In this picture, answers come. but the city gets tired. Third, a scene of smart compromise, closer to real life. Companies and municipalities publish schedules, and we users ask, is it urgent or can it wait? Answers arrive a bit more planned. The total cost drops a notch. At this point, let's add a small parenthesis. The feeling, what difference does my single question make, is also very common. Of course, we're not telling anyone, don't ask. Asking, learning, creating are very valuable. But if everyone says, what difference does my single question make, we end up with billions of single questions. It's like how each driver changing lanes just once can, in total, create a major traffic jam. So the issue isn't blaming individuals one by one, but making the rhythm a bit smarter together. Let's keep asking questions, but if possible, ask more clearly, more planned, more bundled, and sometimes at cooler hours. Let's return one last time to the comparison of tech brands. The question, who's better, is understandable. We want information too, but when we make our perspective a bit fairer, we see that the right comparison is this. Compare the same thing, under similar conditions and with the same scope. In other words, what happens when producing a text of the same length in similar climate and cooling conditions? Are we counting only the water inside the building, or also the water used in electricity generation? When we look within this framework, clear differences appear. But in the big picture, total usage remains the deciding factor. More people, more frequent and longer use. That's why planning and transparency are as important as efficiency, perhaps even more. Let's end with one last example. You have a glass of water in your hand. You set it on the table. The outside of the glass lightly fogs. On the computer next to it, the cursor is blinking. You're about to type a new question. When you look at that glass, remember this. Like everything else in your life, this water is limited. The same is true for cities. AI saves us time, boosts productivity, and sometimes eases our loneliness. In return, somewhere in the world, electricity is consumed, heat is produced, water is used. That means being smart isn't just about getting a good answer, it's about knowing the cost of that answer and acting accordingly. The point isn't to stop asking questions, it's to ask better, ask more planned, and sometimes to wonder, is this really necessary? At the end of the day, everything comes down to this question. Will the intelligence of the future grow by consuming water and electricity, or by protecting them? The answer isn't only in the hands of big companies, it's also in the hands of cities, policymakers, and users like us. When we ask clearer questions, reduce unnecessary repetitions, and use the rhythm of night and day a bit more wisely, we improve the overall impact, even if only a little. When companies share transparent reports, keep water in closed loops, and share waste heat with neighborhoods, and when cities plan accordingly, this story moves in a fairer direction. Every sentence we type on the screen sets an unseen world in motion. If we learn to see, understand, and use that world with respect, we'll both get better answers and treat the place we live better. Intelligence isn't only about finding the right answer, it's about knowing the cost and acting accordingly. Before you write your next question, pause for a second, take a breath, and think, can I ask this question more clearly, more briefly, more deliberately? Maybe yes, and maybe at that moment, a little less water will flow through an invisible pipe somewhere in the world. What we learned today is this. Intelligence isn't only about finding the right answer, it's about knowing the cost and acting accordingly. Let's meet again for our next question, clearer, shorter, more deliberate. Because starting with one drop less, we can make a difference the size of a river.